Let's get started on our second module, which is on creating interactive maps. So far, we have learned how to read various types of geospatial data, vector, raster, gridded rasters, and create some static visualizations. These are great for creating a map for your report or a paper, or if you just want to print it output. But if you want to create an app, or you want to have an interactive map that people can explore and interact with, you need to use some web mapping libraries. So we're going to now switch gears and learn about some of the web mapping packages that are available in Python. Web mapping is a topic which is out of reach for many analysts and many data scientists because it requires you need to know HTML, Python, HTML, JavaScript, and CSS. Those are kind of very different skill set than most people who done data science have. Fortunately, we now have packages that are available in Python that allows you to write Python code to create interactive web maps. The way this works is they take your Python code to describe what you want, and then in the backend, they will take those Python code and what you describe and create HTML, CSS, and JavaScript version of that. And then you get a map at the end. Right? And they allow you to interact with these maps in a notebook. You can take this and put it on an app, put it on a website, or just download that as a static HTML. We'll start with this library called Folium. Similar to in static mapping in Python, everything is based on matplotlib. In Python world, when you're doing interactive mapping, almost everything is based on Folium. Folium itself is based on this really popular JavaScript library called Leaflet. Leaflet is a pure JavaScript mapping library that allows you to write some JavaScript code and create interactive maps that look like this. So you can see this is an interactive map. I can zoom, pan, I can click on a pop-up, and I can create a map like this. So to do this, you need to write code like this. Right? If you have Leaflet as a JavaScript library, you create an HTML page, write JavaScript, and you get an interactive map like this. Folium is a wrapper around Leaflet, which allows you to write Python code with your data in Python and say, create a Leaflet map for me. So it says Python data, leaflet.js maps. You don't need to know any of the things about Leaflet. Sometimes when you're creating something advanced, you may have to go to Leaflet and look at the documentation because some of the options that you want to pass on, there'll be Leaflet options and you can customize some color or line width, etc. from that. But otherwise, you just write code in Folium and then you create your maps. We learned the basics of Folium, how Folium works and how you can create maps. Similar to how we did matplotlib, once we learn the basics, you would never really use matplotlib directly. Similarly, you will not use Folium directly. You will say, I'm using GeoPandas. Instead of GeoPandas plot, if I call geopandas.explore, I'll get a Folium map. Right? So you would use the GeoPandas API to create a Folium map. You will not even go to Folium to create a map. But sometimes, as with matplotlib, if you want something advanced, you have to go under the hood. So it's useful to know how Folium works. And sometimes if you want a very simple map, you don't want to go via GeoPandas, you can just create a map directly using that. So let's see how it works. We'll import Folium. It comes pre-installed with the Colab notebook. If you're running this on your own system, you may have to install the Folium package. The goal for this notebook is that we're going to compute the directions between two cities, get the turn-by-turn direction, and display the route on an interactive map, similar to what you get on a Google Maps. Right? If you search on Google Maps and you get this map, you can interact, zoom, and pan and see that. We're going to create that using the service called Open Route Service. Open Route Service is one of my favorite APIs. I teach that in my Python Foundation course as well. This API uses OpenStreetMap data and gives you functions that allow you to use OpenStreetMap data for routing. It has got API functions for getting directions, computing isochrones, origin destination matrix, also things like route optimization. I have 5 cars and I want to deliver 100 packages. Which car should deliver to where so that my whole route is optimized? You can do those kind of complex analysis here. This is a university project and it's completely free. So you can sign up for an API key, and again, you don't pay for anything. They give you this hosted plan where you can just call the API. It has the latest OpenStreetMap data, and it will get you this just a route back. If you want to use this a lot, you say, I want to do this for 10,000 points, and I want to run this a lot. You can install this library on your local system using Docker and just run that as many times as you want. So it's completely free service. There are some limitations for the hosted version, just so that because it's an open server, we don't want people to abusing that. So you have some limitations, but it's a fairly large limitations that you can use for your research project or even for some production workflows. You need an API key to use this. We had asked all of you to do this beforehand. So once you go, and you need to go to your dashboard, and from a dashboard, you need to copy this API key. And we're going to replace our API key here. So I'm going to paste my API key and run this cell. So if you're following along, please do this. Go and copy your cell here. You will find this key here in your open route service dashboard. Copy this thing and paste it. It is a string. It's a long string. So make sure you have those embedded in a string. The main reason you'll get failures in this notebook is you not entered your API key correctly. Make sure it's a string, so put quotes around it, and you have those cells. Run the cell. Let's see how we can create a Folium map. The idea for the rest of the notebook is we'll take 2 cities, we'll plot a marker on each of those cities and say this is our starting point, this is our ending point, and we're going to plot a route between them. So let's select 2 cities here. We want to plot the directions between San Francisco and New York. We have the latitude and longitudes for both of them. And we want to create a map. So first, we just say folium.map. When we do this, it'll create a leaflet map, a blank leaflet map, and gives us the output. And we save this in the variable m. Now, this m is an object that has the interactive map. If you want to visualize it, you just type m in a Jupyter notebook. When you put just a variable name, variable value in a cell and run it, it just displays what's inside the variable. And what's inside this m is a map. So let's run this one. And you get a basic empty map. And this is an interactive map. I can zoom in and see what the map looks like. One key difference between this and the matplotlib way of doing things, in matplotlib, once you display a map, it goes away, right? It's empty. In Folium, it just keeps there. So if you have an M object, you can keep adding stuff to it, and this map will update. So it doesn't disappear after display. That's the difference. But otherwise, the concept is the same. You create a map, and you keep adding stuff to it. So this will be your figure or an axis equivalent. Now you keep adding stuff to it. One of the stuff that is a little bit problematic is when you just display a map, by default, it's a full screen map. And it makes it hard to have notebook setup. So we can just resize it to be a smaller map. The way to do this using Folium is you create a figure and then set the figure size. And inside that, you put the map. So map will just span whatever is the container. So we first create a container of a certain size and put our map inside of that. And now we have a map. We have done a few extra things. We have created a figure with the height and width. We also, instead of just doing folium.map, we give a location and a zoom. That allows us to say, center my map at this location, at this zoom level. The higher the zoom level, the further zoomed in you'll be. So if I say zoom level 5, the map will be a little more zoomed in. And again, you can kind of adjust it based on your requirements. Since many people want to be able to control the width and height of this, higher level libraries that we learn called leaf map, which is based on this, will allow you to control that from map creation itself. So they'll add extra features that Folium doesn't have, but the root level Folium doesn't have a way to create a map that spans only certain width or height. You just say, this is my map, it'll span the full container. So we create a figure, and inside of that, we add that. There's a question in the chat. What's the CRS of this map? Good question. CRS of all web maps, 5.7. WebMarketer Leaflet only supports 3.8.5.7. There are other packages like OpenLayers. There's a JavaScript-based mapping library that allows you to display map data in different projections, but Leaflet only does 3.8.5.7. So typically, when you add the data, it'll just be reprojected into that. An interesting choice that Folium has made is, and even Leaflet, is that all your input coordinates have to be in lat long. So you say, I want to plot some data, there has to be in lat long. You don't have to reproject it to 3.8.5.7. They'll do the internal reprojection and display this on top. So the input to your Folium and Leaflet map has to be in that long, but the projection that you'll be displayed on is Web Mercator, which is 3857. There's a keyword here, location. This is just the start center of the map. So this is the latitude and longitude of the starting of the map. So when you run this, it's just centered on the United States here. If I change it to some different location, it'll be centered at a different place. Let's add some stuff to it. We want to add the two markers at the location, San Francisco and New York. The way you would do this is you create a marker. So let's look at the documentation. This is the Folium documentation. You can look at different elements here. We want to add a marker to it. So this is how you add a marker. You have multiple options. Location, at what location you want to add a marker. Pop-up is when you click on it, what should be displayed. So it's an interactive map, so people will click on a map. Do you want to display something or not? Tooltip is what will be displayed when you hover on it. Sometimes when you just take your mouse over it, it will display some text. You can do this. Icon, what icon you want to display, and whether do you want this map to be draggable on that. So let's create this marker. So we say, I want my marker. The first argument is the location. And we say pop-up is San Francisco. So we create a marker and we say add to our M, which is our basic map that we had created. Similarly, we create a marker for New York with the pop-up New York and add to M. Let's run this and see what happens. We get a map with two markers. And if I click on it, you get San Francisco. So this is the pop-up will be what happens when you click it. If you want this to be on hover, you can just change it to tooltip. Tooltip is the option that you get when you just hover on that. So now if I just hover on it, I get the text. Many times this is useful from a user interface perspective. A lot of research says that people do not interact with the map. Only the mapping folks like us, we want to click around the map. Most people do not interact with the map. They just see the map and see this. At best, they will hover around. So if you want to show some information, maybe you say, oh, there's some information here. So hover is a good choice rather than say, I want to click it and then display some information. We have the default icon is this map marker, but you can change the icon. There's a huge library of icons that you can use for your pins. Folium icon supports. So if you want to create an icon, you can change the color, what sign, angle, whatever, and then you can give the name of the icon. There are two icon libraries. One is a glyph icon. One is the font awesome. There are two different libraries that are open source, so you can use any icon that is supported from the library. We'll link to this. Let's open up this font awesome. There are thousands of icons here. You can choose any icon here. You can say, I want my icon to be car, or I want my icon to be like a plane, for example. And I can just change the name of that and it'll display that. Here we are saying I want this marker, but icon, I'll just create an icon object, color green, icon crosshair, FA is for font awesome, and I think glyph icon is, if you say glyph icon, you need to pick one from Bootstrap. So we'll just display this as a crosshair. So let me just run this. And you can see my icons have changed. I could change the color, I could change the icon that is got displayed. If I change it to something, let's say, maybe car, or not, let's do plane for now. So if I just do plane, you will display that as a plane. Right? You can just change your icon of your app. A lot of the higher level libraries will choose an icon for you. So if you want to change it, you have to go down to the Folium level and specify an icon object. Okay, I'm going to pause here and see if there's any question. Basic map, basic display of markers. We have our map. Let's display some route between them. So we'll first have to compute the route. The idea is I want the driving directions displayed from San Francisco to New York. I need to compute the turn-by-turn directions. We're going to use the Open Route Service Directions API. This is the Directions API. To use this API, we have to call this URL, api.openrouteservice.org/v2 directions, driving car. They have different options. You can do driving, cycling, walking, etc. But we just want a driving car. So we say call this URL, 3 parameters, API key, we need to give our API key, a start location and end location. And we give this location, you get the turn-by-turn driving directions from OpenRoute service. Let's come and run this. So here we specify start and end locations. These are the 3 parameters, start, end, and API key. Again, every geospatial library expects the order of coordinates in different formats. So read the documentation. Folium says lat long, ORS says XY. So you need to switch your coordinates. So make sure you use it differently. And once we get it back, we will switch it again because OpenRoute service will give you XY. Folium says, I can't plot XY, I want lat long, right? So you have to switch it back. And we call this URL with the parameters. And if the request is successful, we'll read our response and see what we got. Let's run this cell. If it prints request successful, that means your API key was correct, your origin destination was correct, and OpenRoute service was able to find a route between them. A few reasons it would fail. The most important one, you do not have a correct value for this variable ORS API key. So go up and run the cell where you are putting your API key and run this. If you have start and end locations, which are wrong, for example, if your start location is in ocean, it says, I can't compute the route, it will fail. If your start and locations are more than, I think, 4,000 kilometers apart, say I can only compute up to that. So there are kind of restrictions around what you can do. Your start point may be on land, but if it's in the middle of nowhere, there's no road. So if there's no road nearby, using a certain radius will fail. But for most city locations, you should get the response correctly. Let's just see the response, what you got. So if I just print the data, this is what the API sent us. So a lot of data. I want to show the top part. Yes. So this is what you got from the API. It says, you asked me for directions. I would find the directions. The total distance was this many meters. The total duration is this many minutes. This is 4,600 kilometers. I think few 30 plus hours of driving. And then you have steps. So each step, so head northeast on Market Street, turn right, and all the way till New York. Like you have a full 4,000 kilometer turn-by-turn direction that you caught from this API. So pretty cool. You can build your own mapping service if you use this. What we want to do is we want to take this route that was sent to us. So we have the route that has been sent. You can see the full lat long of that. We're going to extract that and then plot that. Let's just extract the data. So the data that we want exists. It's a dictionary that you get back. And we just say we have these coordinates. And let me just show you the first few coordinates. So you can see this is the coordinate of a route starting from San Francisco. We have each vertex showing how to take a turn, which want to go straight and all. This is a long road network. So we have this really long list of coordinates. We have X and Y coordinates, and it's a very big list, and we want to display that on the map. One problem that you have is OpenRoute services, it's XY, so longitude, latitude. And if you try to plot this on leaflet using Folium, it says fail. Sorry, it doesn't work. We need to switch the coordinates of each of those items so that we can plot it on a Folium map. We have this list of lists. We want to switch each item. Again, I've seen people ask this in interview questions. It's a kind of screening question to know whether people really know their Python or not. You can just write a for loop, say for, let's say I want to switch my route. We'll just say route, say for XY in route XY to append, and then we switch our output. So you can see we now take each item and whatever we had X and Y, we keep Y and X. So we switch each of those. This also can be done very easily using a list comprehension. So list comprehension is a syntax in Python that allows you to kind of do this. Instead of creating an empty list, iterating over stuff, appending stuff to a new list, you can do this much more efficiently directly like this. You can create a list and say for XY in route, and you can say YX. So just this particular thing will give you the switch list. It's a single line This is called a list comprehension in Python, which allows you to just do all of this in a single line and just also much more efficient. If you don't know list comprehension, look up and practice that. This will really make your code much more efficient and easy. You can also add if conditions within the list comprehension. There's also dictionary comprehension. If you're reading a dictionary and creating another dictionary out of it, you can use a dictionary comprehension. So let's just use this. We're going to just switch our coordinates. We have all the coordinates switched, and now we can add that. Before we add that, we can also say when people hover over the route, you want to display the total length of the route. So what was the total length and how much time it will take. So we extract the distance from this and we just create a tooltip. We'll just say my tooltip should be a text which will display when I hover over that polyline. It should display driving distance 4693 kilometers, like whatever distance was it. We'll just display that. So we just extracted that value. The distance will be in meters, the duration is in minutes, and we can display that on the map. Okay, now we have our coordinates, we have our tooltip. Let's just create an object. To display a line, we'll use the Folium polyline object. We'll say, create a polyline. These are that long format. This is our tooltip. Let me just do this first. And we say add it to the map. And there you go. We have our route from San Francisco to New York. And if I zoom in, it's actual along each street, right? It just show you each turn and show which highway to follow, right? So it's a pretty complex polyline that we have rendered on that. When you have this really complex polygon and when you zoomed out, you don't really want to see all the vertices. So there's a handy option called smooth factor, which says when you zoomed out, we'll just display a simplified version of it, just to improve the map performance. If you zoom in and out with a lot of complex geometries, you don't waste computation resources rendering that. So if you have something more complex, use that, it'll automatically apply smoothing. So what will happen now is if I zoom in, you'll see my line will get sharper and sharper. As I zoom in, it'll get sharper. And now at the full resolution, I get the full geometry. If I zoom out, you'll see that this will get little coarse. But at this zoom level, it's okay to do this. But it'll really improve the performance of zooming in and out. So we could just start from two locations, compute the directions, and create this nice interactive map with turn-by-turn directions. It'd be nice to save it. Maybe let's say you want to put this on a website. Say I have a blog, I want to put this on my blog. I want to put this on my website, or I want to share it with somebody. How do I share it? Similar to how we could save a plot as a file, we could save our output to any path. So you can say, I want to save it as an HTML file, directions.html, and I can say m, which is our object that we've done, dot save output path. And now I get this HTML file. Let me download this. This is a self-contained HTML file. So there's no external data source. The data is embedded within that. And it contains a map. If I open this HTML file, you get a map. This is the map we created. And it's got the icon, it's got this line with the tooltip, and we can now use this. So if I share this file with somebody, they open this in the browser and they see this interactive map. You can embed this in your blog and you can see this map. If you know HTML, JavaScript, CSS, you can open this and edit whatever you want. What Folium helped you is you just created this HTML file using Python. Let's do an exercise where you will compute the directions between your two cities and make some changes to the visualization.
Yeah, so for the exercise, we want to create an interactive map of driving directions between two cities. So here we have the full script where we are selecting origin and destination. We are giving coordinates. You have to give the API key here. And moving ahead, we'll see all the parameters, route, everything extracted from the JSON. And we will be changing some parameters here for different visualization. So first point here is to customize the markers icon to a car icon. So here we want icon like this. So you can change the icon here. for both these icons. And another thing is we want to specify some thickness and also change the line to red color. So you can specify those parameters here. So make some changes here and have a visualization like this for two cities that you choose, not the same cities. So you will have to change all of these and also give the key to avoid errors.